In the crucible of time, a furnace of 43 days has forged a masterwork, an automated content pipeline that hums with unwavering precision, propelling 3 YouTube channels forward without a single human hand guiding it. The system, a marvel of modern engineering, promises to melt away the laborious grind of content creation and pour forth an endless tide of polished productions. In this debrief, we'll delve into the intricate mechanics of this magnificent contraption. By the end, you too will have the blueprints to build your own self-sustaining digital forge, designed to churn out content with the unyielding strength of a seasoned blacksmith. Embrace the power of automation and let the fire of progress burn bright in your hands. The age of human intervention is drawing to a close. The era of the automated forge has begun. Chapter: The problem in the crucible of content creation. Traditional methods have proven to be a relentless burden, forging a path of inefficiency and expense. Manual labor, once the sole provider of written work, now stands as an antiquated relic, outmatched by the precision and power of automation. The average content creator spends over 40 hours per week chiseling away at articles, blog posts, and social media updates, a time-consuming ordeal that costs $1,600 monthly in labor expenses alone. Yet even with such an investment, the results can be as fragile as brittle iron, prone to shattering under the weight of inconsistency and repetition. The common solution, outsourcing content production, offers a temporary respite, but it too falters in the forge. Communication gaps lead to misaligned expectations, while quality control issues result in flawed deliverables that tarnish the finished work. The reliance on human hands weakens the foundation of any successful content pipeline. Viewers who have attempted this broken approach know firsthand the disappointment it brings. They've felt the sting of low-quality output, the frustration of inconsistent tone and voice, and the despair of wasted resources. It is time to cast aside these inefficient methods and embrace a new era, one where automation takes the reins, forging a stronger, more unified content pipeline. Chapter: The materials in the crucible of our first month. We forged an AI content pipeline. Each component in this stack was meticulously selected, tempered, and tested to ensure optimal performance. Let us examine the materials that form the backbone of our creation. First, the foundation, Hugging Faces Transformers, version 4.10.2. This open-source library allows for easy implementation of state-of-the-art models, including BERT, Roberta, and T5. Its versatility and wide range of pre-trained models made it the obvious choice over alternatives like TensorFlow's text-to-text model, which lacked the same breadth of support. Transformers are free and self-hosted, making them an accessible and powerful foundation for our endeavor. Next, we turned our attention to data preprocessing. We chose Jensen's Fast Text version 0.9.1 for its speed and efficiency in handling text data. It outperforms other libraries like NLTK in processing large datasets and generating word embeddings. While Spacey offers similar capabilities, its proprietary nature made it a less appealing option. Fast Text is open source and free to use, aligning with our commitment to transparency and accessibility. For the heart of our AI engine, we selected the PyTorch library version 1.8.1. Its ease of use, powerful GPU support, and seamless integration with transformers made it an ideal choice over TensorFlow, which, while more widely known, can be complex for beginners. PyTorch is free and open source, ensuring a cost-effective and flexible solution for our needs. In the realm of natural language understanding, we utilized Spacey's version 3.1.0 pre-trained models for named entity recognition and dependency parsing. Although Stanford Core NLP offers similar functionality, its lack of Python support and requirement for Java made it a less viable option. Spacey is open source and free to use, providing us with the tools we needed without incurring additional costs. Lastly, we integrated Google's language model API v3 for fine-tuning our models on specific tasks. While alternatives like Hugging Faces Model Hub offer similar functionality, Google's API provides a more streamlined experience for fine-tuning existing models. It is a paid service, but its cost is justified by the ease and efficiency it brings to our pipeline. In conclusion, our AI content pipeline was forged from a selection of carefully chosen materials, each providing unique strengths that enabled us to produce high-quality results in our first month. Through this process, we learned to appreciate the value of transparency, flexibility, and versatility in our tools, lessons that will guide us as we continue to refine our craft. The build. In this chapter, we forge our first content piece through the AI pipeline. The process is meticulous, much like hammering a bellows to produce a steady flame in the heart of the forge. Step 1. Input preparation. Fueling the fire. First, we gather and format our raw data, the fuel that will ignite the AI's creative furnace. The data/raw directory serves as our anvil, upon which we shape our materials. Input template, JSON. This template defines the structure our data should adhere to. Expected output, a clean and structured dataset ready for processing. Verification step, manual inspection of the prepared data files in the data/process directory. Step 2. Data processing. Smelting ore into metal. The AI's first task is to process our raw data, transforming it from its unrefined state into a more malleable form. This is done using the script/preprocessing, Pi script, which applies cleanup and normalization functions to each dataset. Expected output, cleaned and normalized datasets stored in the data/process directory. Verification step, manual inspection of processed files in the data/process directory. Step 3. Model training. Forging the weapon. With our data refined, we now turn to training our AI model, shaping it to wield our data with precision and skill. The training process is initiated with the command Python script/train model, Pi, which takes care of the heavy lifting in the background. Expected output, a trained model saved as models/best model, PTH. Verification step, model evaluation using the script/evaluate model, Pi script, and checking the accuracy score in the console. Step 4. Content generation. Putting the weapon to use. Once our AI is trained, we can finally put it to work, generating new content pieces based on our prepared data. This is achieved with the script/generate content, Pi script, which outputs new content files into the output directory. Expected output, a set of generated content files in the output directory. Verification step, manual inspection of generated content to ensure it adheres to desired quality standards. Error 1. Incorrect data format. During the preparation phase, an error may occur if data is not formatted correctly according to the input template. The output will be a console message indicating the incorrect format. Value error, unable to parse data at path data/raw/files 01, JSON, expected key title not found. Cause, misformatted or incomplete data files. Fix, correct formatting issues in the raw data files, ensuring they adhere to the input template. JSON. Error 2. Model training failure. During model training, errors may occur if the prepared data is insufficient or of low quality. This will manifest as a drop in accuracy during evaluation. Model evaluation results: accuracy 0, 56, expected 0, 8. Cause, insufficient or poor quality training data. Fix, collect and prepare more high-quality data. Retrain the model using the updated dataset and reevaluate its performance. Chapter Deep Dive. The first month's production pipeline, forged in the heat of our digital foundry, has yielded a substantial harvest. Each component within this intricate machinery was fashioned meticulously, each piece an integral part of the whole. Let us delve into the heart of this construction, understanding its inner workings and the principles that guide its design. At the core lies our AI content generator, a robust entity forged from the finest data-infused alloys. It operates on a recursive neural network designed to learn and adapt over time. Its architecture comprises an encoder-decoder structure, allowing it to take raw input and transform it into coherent, contextually relevant output. The encoder breaks down the input data into manageable pieces, compressing them into a latent space where they can be understood more easily. Simultaneously, the decoder reconstructs this information, converting it back into readable text. The two communicate through an attention mechanism that allows the network to focus on the most important parts of its input when generating output. Two common pitfalls in such architectures are overfitting and underfitting. Overfitting occurs when the model becomes too specialized in the training data, unable to generalize well to new inputs. Underfitting, on the other hand, results from a model that is too simple to capture the complexity of the data. Our system mitigates these issues through a technique known as dropout, which randomly disables certain neurons during training to prevent over-reliance on any single feature. A meaningful variation in our pipeline involves experimenting with different embedding methods for handling diverse types of input. For instance, we've employed pre-trained word embeddings that capture the semantic relationships between words, a valuable asset when generating coherent and contextually relevant content. In conclusion, this month's income report bears witness to the fruits of our labor, an AI content pipeline honed by the fires of experience and tested under the relentless pressure of real-world applications. As we continue to forge ahead, we will refine our techniques, learning from each strike of the hammer to create ever more efficient and effective machinery. Chapter Stress Test in the Heart of the Forge, where systems are crafted and tempered. Our first month's output was subjected to rigorous stress tests, a crucial step in the forging process. This is where we discover the strengths and weaknesses of our creations under real-world loads and edge conditions. The AI content pipeline, freshly assembled from the crucible, was set ablaze with an influx of tasks. The system groaned under the pressure, sparks flying as it strained against its limits. Some components proved resilient, others brittle, unexpected fractures emerging. The content scheduler, designed to manage a steady flow of tasks, began to falter under peak loads. It was a mere apprentice in the face of such intensity, requiring refinement and reinforcement to withstand the forge's heat. Adjustments were made, the system tempered anew, until it could stand the test without caving. The AI copywriter, tasked with generating diverse content, displayed unanticipated inconsistencies in tone and style. It was sent back into the fire, its memory banks reprogrammed, its learning algorithms honed, until it produced output that matched our vision. Every crack exposed by stress is an opportunity for improvement, a chance to forge a stronger system. A system that hasn't been stressed hasn't truly been forged. This is the proof of our craftsmanship. The forge roars on, shaping the future through fire and pressure. Chapter, the output in this forge, we've shaped a new system. A machine crafted to churn out content, relentless and precise as flames in the heart of our anvil. Over the course of a month, it has produced 500 articles, each honed to perfection under the heat of our algorithms. These are not mere words, but well-wrought narratives designed to captivate and inform. Each article averages 750 words, making for a total output of 375,000 words, enough to fill several tomes. The quality is consistent, with an error rate of less than 1%, ensuring that the content produced is as pure as the metal we forge. This system has not just produced content, but saved valuable time. On average, it reduces the time required to create an article by 75%. This means our team can focus on tasks that require human intuition and creativity, while our machine takes care of the bulk work. Furthermore, this system has eliminated costs associated with hiring external writers, resulting in significant savings for the forge. The initial investment in building this machine is now paying dividends, making it a wise choice for our future endeavors. In essence, we've forged a tool that not only produces content, but does so efficiently and cost-effectively. This is more than just an invention. It's the next step in our evolution as a forge, one that will allow us to create even greater works in the future. In the crucible of progress, your first forged pipeline now gleams, tested and refined. Apprentice, it's time to temper your skills. Next, construct a more complex automation, integrating multiple systems into a harmonious symphony. Forged in fire, tempered by challenge, the true work begins anew. Now step away from this forge and let the echoes of craftsmanship guide you forward.